So let's talk about the pump jack, the nodding donkey, or as it would be more correctly called, the beam pumping unit and the sucker rods. Two YouTube videos for you to watch here. They're a little bit comical because the guy is a little bit funny just because it's slightly old-fashioned. The first one's an excellent discussion of what happens above the surface. The second one's a discussion of what happens below the surface. Second one gets a little more detailed than you need to worry about. So just watch the first part of the second video and you should be good to go. So again, I'm going to pause and let you watch those videos. Welcome back. Like I said, you did watch those videos, right? You can see it's a very simple concept. And what happens is they bring out the pump jack when the formation pressure is no longer such that the oil will get to the surface all by itself. Here's an interesting question for you. Can they use a pump jack on a horizontal well that has a long lateral? The answer is they actually can, which kind of surprised me. But again, it's just like they bend that casing around the bend and the drill pipe around the bend. The sucker rods can go around the bend as well. We're going to look at something that's also used in addition to pump jacks in the next slide. But again, we're used to seeing these all over Texas, and now you know how they work. The newfangled thing is called the electric submersible pump, or ESP. Another YouTube video. This one's relatively short, no narration, just gives you a sense of what it's used for. ESPs in theory are great for horizontal wells because they don't have all that metal that has to bend necessarily. They're also good for wells that have a high proportion of gas because obviously the gas could cavitate some of the beam pumping units, and because this does a little bit of separation, it should help with that. Also, they can produce a lot of fluid like this. The downside to ESPs is, frankly, that they're a lot more expensive than our pump jacks. They also, because they're in the oil, they do corrode quite a bit more quickly. So now we've been working our pump jacks full time, and it's just not as good as it used to be. And it's time to start thinking about some improved oil recovery. The main technique is the water flooding, and the YouTube video is going to do a great job of letting you see the graphic on this. And I can tell you here in the immediate area of Wichita Falls, this is what a lot of wells are under. They are under water flooding programs. And the cool part about it is they use the produced water that they bring to the surface, and they re-inject it after it goes through the separator, so that they're pumping the water back down under the ground, which saves them the disposal costs. So that's pretty neat. So take a look at this YouTube video, which does a great job of describing the water flooding process. Now we're into the idea of enhanced recovery. Remember, the difference between improved and enhanced is that in enhanced, you're physically changing the nature of the oil. In that YouTube video where they were talking about water flooding and they were talking about the injection of CO2, that was actually an enhanced technique because they talked about making the CO2 chemically altered slightly so that it was easier to transport by the water. You can do that just by purely injecting carbon dioxide on its own. Also, another technique is the steam recovery. This is the one that they use out in the Kern River based in California. So I encourage you to take a look at that video that will explain how it works, and obviously it talks about the results it had. You can also use various chemicals in it, and the next YouTube video is going to show you some of the different chemical types. The issue with enhanced recovery is that all these things begin to get expensive. And that gets into our closing thought on all this. Tell me, what do you think the critical questions are when you're considering either doing some improved oil recovery or enhanced oil recovery? That's right. The two major questions are, A, how much additional oil is this going to generate? And B, what's it going to cost to do the procedure? And so those questions are answered without a lot of certainty, I might add. They're guesses, and so there's a risk involved in doing these sorts of things. Also, the question comes up, particularly with the horizontal wells, can you refrac them? Just now getting into the area where companies are doing this more and more, and the answer seems to be yes, you can profitably refrac a well. Same sort of thing. What's it going to take? What's the nature of the sorts of wells and the locations and the reservoirs as to where it's going to be effective. There's not a tremendous amount of data out there on the effectiveness of this. If you read the industry periodicals, they're talking about this. When does it make sense to refrac? When doesn't it? What are the procedures? As is true with fracking as a whole, we're still very much in the early stages of a lot of the fracking to understand what is the optimum way in terms of well separations, how much pressure, how much sand, and all those sorts of things. But now the oil is to the surface, but it's not quite good to go yet. Join me in the next video where I talk about that.